Welcome to this short introduction to how to do our schematic setup of architectural design following this line of actor, mask, stage and image in Mathematica. So it's important that you understand that all these architectural structures we want to learn are independent from a certain implementation. So, therefore I want to show you that in Mathematica, in code, what we already did in Blender, and that's interfaces, what we did with the Python. But in Mathematica, you're much more flexible to do this modeling of your architecture. Therefore I want to show how graphics work there, and you will see the parallels. It's not important that you actually do that, it's important that you understand these kind of symmetries which appear if you look at this. So therefore it will be very fast. If you are interested in Mathematica, there will be another set of tutorials. So the graphics in Mathematica is working like that. So you say it's graphics, that's the renderer. And then you give a certain color, then you say it's, for example, a disk, it's at coordinate 000, now we're in 2D, it's 1/3, and this is the circle. So you can add other, for example, blue, then you say disk should be at 110, and then you see this is the graphics. The stage are the options of the graphics. For example, you can say plot range and say it's 2. Then you say axis true. These kind of things. So therefore it's a little complicated to keep these things separate, as it is complicated to keep it separate for architectural purpose and the interfaces of Blender. So I suggest using Mathematica in this way. So there is our Digital Architectonics lecture series. It's a second semester 6 talk, and you can find the file in the appendix of this video. So if you want to go 2D, to set up the stage, it's a little tricky like we had it in Blender. So it's a lot of different parameters and you simply have to understand that. So it's or to copy that and so on. It's complicated but not complex. You simply use it as proposed. So don't try to understand. There's nothing to understand. Simply do it like that if you want for this result. So what we do is we get the graphics. We have the play, which is this, and we simply symbolize that, and then we have all these parameters here. And we have here the plot range, so it's a size, and give that as a parameter, and then make a grid on the size and so on. So for example, if we go here for 26, it's getting bigger. If we go here for -4, -4, no, 4, in X, and then Y from -4 to 4, then we get a bigger one, and so on. So that's our stage, and we symbolize it simply with stage, and we don't want to do anything with it any longer. So just take it in our initial thing. So now our play. Go here for the next step. Oh, this is 3D. This is our stage. Go for the next step, the actor. So now we say actor 1, is, for example, the rectangle, and this goes from minus 0.5 to 0.5. So now if we say stage 1, play actor 1, then we take stage 1 as it is and we replace this play by actor 1, which is this code, which means we get our actor presented here. So if we have an actor 2 as the disk 1/3, and we say we want to have actor 2, then we have actor 2. If we want to change this parameter, then it's getting bigger. So that's the stage, that's the actor. Now the mask. So we are still in the libraries. What you have here, this is a library of actors, of meshes and Blender, and now we are get to the library of the materials. So this simply, we go here for the mask. So we say it's a figure or roll. Roll 1 is, and we had it here, so is red, for example, disk. So we can say red of actor 1. So if we now say stage 1, not actor, but roll 1, then we get this red rectangle. So we can add, for example, opacity .5, and then we have an opaque actor 1, roll 1, put that on stage 1. So have that. So we can have a library of different materials, or to get a more figurative understanding, it's not materials, it's the mask of an active element, of an actor, so to play a certain role. So third steps are the directives. They are here. So it's all 3D. So to make it simple, so we have the geometric transformation. You see, for example, translation transformation. These are matrix functions. So you see all these functions here. You see the transformation is move it from here to here. Graphics. You see this is the kind of intermingled, from an architectural perspective, unstructured kind of doing your graphics, like the interface graphics in Blender, the same in 3D and so on. So that got very long. Therefore, I simply define GT as geometric transformation, transfer, and so on, to make it shorter. So now we say play 1 is a geometric transformation of roll 1, and then we say translation transformation, which is a movement by 1/0. So let's play 1. Our directive. So again, if we get here stage 1 and we say play 1, then our actor with his mask moves on stage. So now we can go here, for example, if we add a second one, give the same actor or the same player Another so here coordinate a second directive, then he will do both. Yeah, good. These are the steps. So you have the actor, the mask, you have then you have the play with the directives, and you put that on stage. So if we want to have that in a comprehensive view, instead of having this, I suggest doing this with a predefined stage. So you have the actor. This corresponds to our meshes. This is a library of meshes in Blender. So this is a library of materials. These are at the outliner. It corresponds to the outliner. This is the actual and the 3D view. This is the actual architectural design, and this is just the rendering. If we want to have that as an image, then we can take a picture of that in a certain size and so on. So let's look at it, run that, play, roll, whatever. So here we are. This is our graphics, and this is the actual print of it. So now it's clear. If we want, for example, another figure, go here, extend this library, and it's getting very simple to play with it. So make that a disk, 1 by 300. Here, actor 1, the role is this. Take role 2 is minus figure 2. So play role 1 and role 2. And here we are in our production line. So if you say the red picture should be a circle, do it, and here we are. So if we want to have a second position of figure 1, then you copy that and make a list of this, make instances of this, and you say this should be at 3/2 and this should be at 1/2. And here we are. So therefore you see, this is a very clear overview of how to connect your things. It gets very compact. You have to understand and to read the code, but these connections are crisscross, and this is a very compact description how to unfold a certain spatial configuration, your architectonic layout. So that's it, and I hope you find it interesting, and there will be some more videos on Mathematica in parallel to Blender. You're invited to learn that. I think in Mathematica it's the most appropriate way to do your modeling, architectural modeling. If you go to the design of your objects, it's simply not adequate to do that in Mathematica, unless you are not working on certain formulas and so on, discretization of these formulas. But there will be this interplay. So you do your design with a CAD system and do your architecture like this with some code, either in a comprehensive Python or whatever you like, or I suggest in Mathematica. Thanks for watching. See you in the next tutorial. A third plan, a short appendix. If you want to have that in 3D, it might be interesting to see that there is no structural difference in how to work with it. You need another renderer, of course, and then of course you need to add the third dimension in your coordinates. We have it here. So I want to show you that there's no principal difference in how to establish that. So then we need another stage. So that's the first thing, because it should be 3D. So the 3D stage again is a little tricky. We call it stage 2. So go here for 3D, and we say stage 2, and say play. And here, this is, you can look it up how it works. So this is our stage 2. So now take the code as it is and go here. Actor 1 is the rectangle. We need the third. So let's take its cuboid. It's 000 minus 0.5. It's not a disk, it's a sphere, so it needs the third dimension. So figure, actor, that's fine. So we don't need to change these things. Roll, figure, translation, we say okay, it should be level 1, should be, or go here for on 1, do the same here on 1. Here on 1. So we get the third dimension, so it's a little up. Play, stage 2, roll 1, and image, play, and here we are. So I find that very impressive, that the things are in the same structure, 2 and 3D, and your architecture is consistent. That's important. So therefore all the renderings, whatever you take, 2D, 3D, or for building information models, for example, all these calculations on these tables and summing ups and lists, just renderings. Your architecture is unaffected by that. It's just the structure and the symmetries of your code. Thanks for watching. No, it's definitely at the end.